Good day, grade 7 learners. This is Super Mom Z and welcome to Sci Amazing Learning Videos. For this episode, we will describe motion in terms of distance and displacement. Are you ready? Let's go! Most essential learning competency. The learners should be able to describe motion in terms of distance and displacement. Before we dive into these two concepts, let us first define motion. What is motion? Take a look at these animations. Right, all of them are moving. Motion refers to any change in position for a particular time interval. In other words, we can define motion by asking the question, how far did an object travel from a reference point? A reference point is a place or object used for comparison to determine if something is in motion. Just like in this example. What is the object in motion? Correct. The object in motion is the ball. What is the reference point, or the object we use to determine if something is in motion? Fantastic! The reference point is the ring. Now consider this example. There is a tree and there is a moving dog. We can also spot some measurements such as length and time. If the reference point is the tree, how far is the initial position of the dog with respect to the tree? Perfect. The initial position of the dog with respect to the tree is 5 meters. Now, how far is the position of the dog with respect to the tree 15 seconds later? Nice! The position of the dog with respect to the tree 15 seconds later is 15 meters. We can actually answer the question, how far did an object travel from a reference point, by determining its distance and displacement. Let's talk about distance first. Distance is the total length of path traveled by an object. It is a scalar quantity, meaning it only has a magnitude. It doesn't have direction. Keep in mind that if an object is moving, it changes its position and the distance is not zero. In this figure, for example, the dog ran 10 meters to the east, then 5 meters to the south, and another 10 meters to the west. What is the distance traveled by the dog? Good job! 10 meters plus 5 meters plus 10 meters are all equal to 25 meters. The distance traveled by the dog is 25 meters. Now, let's take a look at displacement. Displacement is the shortest distance between the object's two positions. As you can see in the figure below, distance is represented by broken lines. These lines show the entire length traveled from point A to point B, while displacement, as represented by a continuous line, shows the shortest distance between the 2 points. Unlike distance, which is a scalar quantity, displacement is a vector quantity. It has a magnitude and direction. For example, it can be written as 150 meters east or positive 150 meters. Also remember that displacement can be positive, negative, or zero. If you move in forward direction with reference to your initial position, then its value will be positive. When you move from point A to B, the value is positive as it moves in forward direction. However, if you move in backward direction with reference to the initial position, then its value will be negative. In the previous example, how can we compute for the displacement? Right, you can place the continuous line here. The displacement is 5 meters south, while the distance is 25 meters. Can you now differentiate between distance and displacement? Very good. Finally, let us apply what we have learned in this example. A busy day in the life of Mr. Ant. Today is a workday for Mr. Ant as he is preparing to look for food that he can store for consumption in the next few days. He is determined to finish his task within the day and is planning to spend the night with his friends. Let us help Mr. Ant get through his busy day by studying the illustration below and completing the data in the given table. In this table, you are given a scenario. What you need to do is to draw in the Cartesian plane and answer the questions provided in the columns. Scenario number 1. The path that Mr. Ant needs to travel from his initial position towards the location of the first food stack. Let's take a look at the diagram. So here we can see the ant has to travel 2 meters up. So in the Cartesian plane, we just have to draw a line with an arrowhead up to 2 meters. Now the question is, what is the length of the path? Of course, that is 2 meters. How far is Mr. Ant's final position from his initial position? Looking at the diagram, we can see that the ant's initial position is at 0 meters, and it went up to 2 meters for the first food stack. Therefore, Mr. Ant's final position is positive 2 meters. That is how far he is from his initial position. And finally, for the interpretation, Mr. Ant moves 2 meters north. Did you get it? Wonderful. Scenario number 2. The path that Mr. Ant needs to travel from his initial position towards the location of the first food stack, then goes to the ant hill to store the food. In the diagram, I placed 3 arrows here. The middle arrow shows the initial position, the upper arrow shows the first stack, and then the lower arrow shows the anthill. So in the Cartesian plane, we just have to draw a line with an arrowhead up to 2 meters, then another line with an arrowhead downwards to negative 3 meters. Now the question is, what is the length of the path? 2 meters plus 5 meters equals 7 meters. That is the length of the path, the distance Mr. Ant traveled. How far then is Mr. Ant's final position from his initial position? Looking at the diagram, we can see it is negative 3 meters, so we write that on the 4th column. Lastly, how do we interpret this data? Mr. Ant moves 3 meters south from his initial position. Yay! Were you able to follow? Good job. In summary, here are the differences between distance and displacement. Distance is the entire length traveled, while displacement is the shortest distance between the points. Distance is a scalar quantity, while displacement is a vector quantity. Distance has a positive value, while displacement can be positive or negative. Lastly, distance cannot be zero, while displacement can be zero if an object starts and ends on the same spot. I hope you learned a lot about distance and displacement in this amazing episode. See you again next time. Bye!